In this example problem, we're going to do a calculation involving a contact lens on an eye. This is our ultimate goal. We want to determine the correct power of the contact lens that will allow this person to see a distant object clearly. Our information going into this is that the person is nearsighted. They cannot see distant objects clearly. They can see near objects clearly. And they currently have a correction with minus 4.7 diopter power on the lens. That lens mounted 1.9 centimeters from the eye. Then they can see a distant object clearly. So let's see what we have here. A little sketch of the situation is appropriate. So we have the person's eye, our negative lens, and the distant object, a mountain or some other object perhaps. Our basic equation for this calculation is 1 over the object distance plus 1 over the image distance equals 1 over the focal length. For a very distant object, our object distance is near infinity. So from that information, that'll be helpful. It's going to simplify this equation a lot. What about the focal length of the lens? Well, focal length is related to the power of the lens through an inverse relationship. So the focal length is 1 over the power, 1 over minus 4.7 diopters, gives us minus 0.213 meters. When we invert power, we get meters. Or in centimeters, minus 21.3 centimeters. Minus is appropriate because this is a negative lens, so-called negative lens, concave. So going into our equation, object distance, I put in infinity. Di is unknown, minus 21.3. And 1 over infinity, that's a 0. So we have 1 over di equals 1 over minus 21.3. Di must be minus 21.3. And this is our image distance, So I don't know if I can't sketch this very well, but our image is on the same side as the object. That's why it's minus sign. And we have 21.3 centimeters from the lens. 21.3 centimeters from the lens. How far is it from the eye? Well, it's 1.9 centimeters from the lens to the eye. So this image is 21.3 centimeters from the lens. We add on 1.9 centimeters and we obtain the distance where this person can clearly see an image, and that is 23.2 centimeters from the eye. If the object is farther away than that, they cannot see it clearly. This lens is bringing very distant objects into proper focus, 23.2 centimeters from the eye. That's going to be useful for our contact lens. Our contact lens should create this upright image of the distant object at this same location, 23.2 centimeters left of the eye. Well, how could we find the power of the contact lens that will accomplish that? Again, DO is infinity, so 1 over DI equals 1 over F. We know the image distance. We need this image to be 23.2 centimeters left of the eye on the same side as the object. So I write it as a negative. When we're on the same side as the object with our image, that image distance is a negative for a simple one lens calculation. So the focal length is obviously minus 23.2 centimeters or minus 0.232 meters. If I convert to that, as I need to do before we calculate the power is 1 over the focal length in meters. So we get a power of minus 4.31 diopters, minus 4.31 diopters. That's a little different than the power of the lens that was minus 4.7 because of this 1.9 centimeters from the eye where the lens was mounted. The contact lens is right on the eye, so this 1.9 centimeters does not come into that calculation. Gives us a slightly different power for the contact lens versus the glasses. So if you need to, pause and go back to a certain location in my verbal comments. Ask your instructor questions. If you'd like a list of other physics and astronomy tutorials, these websites list those videos with a short description of what's involved with each one and how long they are. There's nothing to buy at this website. You don't register. You just get, hopefully, useful information. So keep practicing your physics problems and ask your instructor questions when they come up.